In the vast universe, our solar system is just a small but fascinating part, with each planet and celestial body presenting its own challenges and mysteries. Space exploration is a testament to human intelligence and creativity, as we continuously expand our understanding and capabilities. While visiting nearby planets may seem like the next natural step in space exploration, the reality is far more complex. Each journey, from Mercury to Proxima Centauri, encounters difficulties that challenge the limits of our current technology. These challenges include extreme temperatures, dangerous radiation, massive gravitational forces, and vast distances. However, with each challenge comes the opportunity to discover wonders. From the potential existence of life beneath Europa's icy surface to the dream of sending humans to Mars, space exploration continues to inspire and push humanity forward. Let's dive into the difficulties of exploring planets and the exciting destinations in the solar system and beyond, starting with the planet closest to the Sun, Mercury. At first glance, Mercury seems like one of the most accessible planets. Its proximity to Earth suggests that reaching it should be easy. However, the reality is quite the opposite. Mercury's close orbit to the Sun presents unique challenges, making it one of the hardest planets to visit. First, its proximity to the Sun exposes spacecraft to extreme temperatures. Daytime temperatures on Mercury can reach up to 430 degrees Celsius, while nighttime temperatures can drop sharply to -180 degrees Celsius. This vast temperature fluctuation requires the development of advanced heat shields for any mission to this planet. Spacecraft must also be equipped to withstand intense solar radiation, making the journey even more dangerous. Additionally, because Mercury is so close to the Sun, any spacecraft approaching the planet is pulled by the Sun's strong gravitational force. As the spacecraft nears Mercury, it rapidly accelerates toward the Sun. Controlling this speed requires a massive amount of fuel to slow down and enter Mercury's orbit. This issue is further complicated by the limited fuel capacity of most spacecraft. Without an effective way to decelerate, missions risk overshooting Mercury's orbit or crashing into its surface. NASA's Messenger probe, launched in 2004, is a brilliant example of human creativity in overcoming these challenges. The journey to Mercury took 7 years, following a complex trajectory with multiple gravity assists. By using the gravitational pull of Earth, Venus, and even Mercury itself, Messenger was able to gradually slow down and adjust its orbit, finally settling into orbit around the planet. Messenger's mission was a landmark in planetary exploration. It provided the first detailed maps of Mercury's surface, revealing a world shaped by volcanic activity and impact craters. One of its most surprising discoveries was the potential presence of ice at Mercury's poles, an unexpected find considering the planet's extreme conditions. Using solar sail technology, Messenger demonstrated that innovative engineering could overcome fuel limitations, a common obstacle for missions to Mercury. Messenger's success paved the way for future explorations, but also emphasized that sending a spacecraft to this seemingly close planet is far from easy. While Mercury poses great challenges, Mars, the red planet, has captured the attention of scientists and the public alike. Mars is often seen as the next frontier for human exploration, with the potential to become humanity's second home. However, sending humans to Mars is not just a matter of ambition. It is a colossal challenge that requires overcoming numerous technical and logistical hurdles. The distance between Earth and Mars varies depending on their positions in orbit, but at its closest, Mars is still about 54.6 million kilometers from Earth. A human mission to Mars would take about 6 to 9 months one way, depending on the spacecraft's speed and trajectory. This is far longer than the 3-day trip to the Moon, making mission planning much more complex. One of the biggest challenges of a manned mission to Mars is the large amount of supplies needed. A round trip to Mars, including time spent on the planet, could last up to 914 days. During this time, astronauts will need food, water, oxygen, and other essential supplies. Additionally, the spacecraft must be equipped with long-lasting life support systems to sustain human life for nearly 3 years. Another concern is radiation. Unlike Earth, which has an atmosphere and magnetic field to protect us from solar and cosmic radiation, Mars lacks these protective layers. Astronauts traveling to and living on Mars will be exposed to much higher levels of radiation, increasing the risk of cancer and other health problems. Developing radiation shielding will be crucial to ensuring the safety of future Mars explorers. Fuel is another major challenge. To send humans to Mars, a massive amount of fuel is needed, not only to propel the spacecraft to Mars, but also to bring the astronauts back to Earth. This means multiple rocket launches will be required to transport all the necessary equipment, materials, and fuel for the mission. Additionally, scientists are researching the possibility of using resources on Mars, such as ice, to produce fuel for the return trip. Despite the many challenges, space agencies like NASA, along with private companies like SpaceX, are determined to make human missions to Mars a reality. Recent technological advancements, including the development of reusable rockets, are important steps toward this goal. However, the journey to Mars will be long and challenging, requiring unprecedented cooperation, creativity, and persistence. Jupiter, the largest planet in the solar system, also presents its own challenges for exploration. While Jupiter's massive gravity helps spacecraft reach the planet easily, maintaining orbit and conducting meaningful explorations is much more difficult. Jupiter's strong gravitational pull causes spacecraft to accelerate rapidly as they approach. Slowing down enough to enter orbit requires a large amount of fuel or assistance from the gravitational forces of Jupiter's moons or other planets. Even if a spacecraft successfully enters orbit, Jupiter's intense radiation belts pose a significant threat to both the spacecraft and its onboard instruments. Jupiter's atmosphere is another major obstacle for exploration. The atmosphere is mostly composed of hydrogen and helium, creating immense pressure as you go deeper. Any spacecraft attempting to descend into Jupiter's atmosphere would be crushed long before reaching the planet's core. Despite the difficulties, several missions have provided valuable data about Jupiter and its moons. The Pioneer and Voyager missions gave us our first close-up images of the planet, revealing massive storms and colorful cloud bands. The Galileo mission, launched in 1989, spent 8 years orbiting Jupiter, sending back detailed images and data about the planet's atmosphere and moons. One of Galileo's most remarkable discoveries was volcanic activity on Io, one of Jupiter's moons. The spacecraft also found strong evidence of subsurface oceans beneath the icy crust of Europa, another of Jupiter's moons. These findings have fueled speculation that Europa might harbor life, making it a key target for future exploration missions. NASA's Juno mission, currently orbiting Jupiter, continues to provide valuable insights into the planet's composition, magnetic field, and weather phenomena. By studying Jupiter, scientists hope to gain a better understanding of how the solar system formed and the role gas giants play in planetary formation. Saturn, the sixth planet from the Sun, is famous for its beautiful rings, but reaching this distant world is no easy feat. The vast distance between Earth and Saturn means that spacecraft must travel for years to reach their destination. Furthermore, Saturn is too far from the Sun for solar power to be practical. Instead, missions to Saturn must rely on nuclear power sources for electricity. The Cassini-Huygens mission, a collaboration between NASA and the European Space Agency, ESA, is one of the most successful missions to Saturn. Launched in 1997, Cassini spent 13 years exploring Saturn and its moons before plunging into the planet's atmosphere in 2017. Cassini provided a wealth of data about Saturn's rings, atmosphere, and magnetic field, as well as detailed images of its moons, including Titan and Enceladus. Titan, Saturn's largest moon, is particularly intriguing because it has a thick atmosphere and lakes of liquid methane on its surface. Scientists believe that Titan's environment might resemble early Earth, making it a prime candidate for future exploration. The Huygens probe, part of the Cassini mission, successfully landed on Titan in 2005, providing the first direct observations of this mysterious moon. Enceladus, another of Saturn's moons, also captured the attention of scientists. Cassini discovered that Enceladus has geysers that spew water and ice into space, suggesting the presence of a subsurface ocean beneath its icy surface. This discovery has led to speculation that Enceladus could harbor microbial life, making it a key target for future missions. One of the biggest challenges of exploring Uranus is its great distance from Earth. At an average distance of about 2.9 billion kilometers, 1.8 billion miles, it is one of the farthest planets in our solar system. Reaching a planet this far requires spacecraft to operate for extended periods without relying on solar power like those visiting closer planets. Therefore, missions to Uranus will need to use nuclear power sources to keep the spacecraft systems running. Another challenge is the long travel time to reach Uranus. With current technology, a trip to the planet could take over 15 years, complicating mission planning. Furthermore, as the spacecraft approaches the planet, the diminishing sunlight makes it difficult to observe and gather data. To date, only one mission has flown close to Uranus, the Voyager 2 probe. In 1986, Voyager 2 passed by the planet and provided the first images of Uranus, including information about its atmosphere, magnetic field, and moons. However, much remains unexplored about the planet, especially its atmospheric dynamics and unusual magnetic field. Scientists are still figuring out how to plan new missions to Uranus. New discoveries about this planet could offer insights into how ice giants form and develop, as well as help us better understand the evolution of the solar system. Neptune, the eighth and farthest planet in our solar system, is one of the least explored planets. Its average distance from Earth is about 4.3 billion kilometers, 2.7 billion miles, making it one of the most challenging destinations for any space mission. To date, Voyager 2 is the only spacecraft to have flown close to Neptune. In 1989, Voyager 2 passed by the planet and provided the first close-up images of Neptune's turbulent atmosphere, including strong winds, dark spots, and faint rings surrounding the planet. However, this encounter was brief, and many mysteries about Neptune remain unsolved. One of the main reasons scientists want to return to Neptune is its largest moon, Triton. Triton is unique because it orbits Neptune in the opposite direction of the planet's rotation. This has led to the hypothesis that Triton might be a captured object from the Kuiper Belt. Triton has an icy surface, and there are signs of cryovolcanism, where materials like water ice and volatile compounds are expelled instead of molten lava. Data from Voyager 2 suggests the possibility of a subsurface ocean beneath Triton's icy surface, which raises the possibility that Triton could support life. This possibility makes Triton a key target for future exploration missions, with the hope that we can uncover more secrets about this distant planet and the wonders it holds. While the planets in our solar system present significant challenges, the greatest challenge we face is interstellar travel, venturing beyond our solar system to reach the nearest stars. Proxima Centauri, the closest star to Earth, is about 4.24 light-years away, equivalent to more than 40 trillion kilometers. With current technology, a trip to Proxima Centauri would take thousands of years, making interstellar travel a highly ambitious goal for space exploration. However, scientists are researching advanced propulsion systems that could reduce travel time to nearby stars. Ion engines, nuclear propulsion, and solar sails are promising technologies that could help spacecraft travel faster and more efficiently through space. One of the most notable projects in interstellar travel is the Breakthrough Starshot initiative. This initiative, funded by billionaire Yuri Milner, aims to send small spacecraft to Proxima Centauri at speeds of 15% to 20% the speed of light. While these spacecraft will not carry humans, they could provide valuable data about the Proxima Centauri system and its potentially habitable planet, Proxima b. If successful, this would be the first major step toward exploring other star systems and learning more about the universe beyond the solar system. Space exploration is not just a scientific endeavor. It is a testament to humanity's curiosity, resilience, and desire to explore the unknown. Each planet and star presents unique challenges that require creative solutions and advanced technology. From Mercury's extreme temperatures to Triton's icy regions, space exploration continually pushes the boundaries of what is possible. As we continue to explore the solar system and beyond, the lessons we learn will not only help us understand our place in the universe, but also provide valuable insights into the challenges we face on Earth, such as climate change and resource management. The future of space exploration promises to be full of wonders, and with each new mission, we come closer to unlocking the mysteries of the cosmos.